Hello everyone, thank you for being here today. We are excited to present our topic on the observer pattern, an important design pattern in software development. Before we begin, let us introduce ourselves. We are team number 2, including Nguyễn Gia Huy, Đặng Hữu Lộc, Nguyễn Nhật Quang, and Nguyễn Quang Sáng. Today, our team will explain how the observer pattern works in real-world applications and why it is essential in software design. Let's get started. Before we begin, let's have a look at the table of contents. First, we will have introduction to observer pattern. We will understand the basics. Then, key concept. We will see the core component. Next, key structure. It's all about UML diagram and architecture. Number 4, implementation steps. Number 5, real-world example. And number 6, benefits and drawbacks. Number 7, implementation example. And number 8, conclusion. First, introduction to observer pattern. The observer pattern is a behavioral design pattern that allows an object called the subject to maintain a list of its dependents called observers and notify them automatically of any state changes. The observer pattern comes under the behavioral design pattern. It is also known as dependence, publish, subscribe, and model view. The purpose of behavioral design pattern is to define how objects communicate and collaborate while maintaining flexibility and reducing dependencies. They help structure interactions between objects efficiently. Behavioral has these key features that differ them from structural and creation pattern: encapsulate behavior, loose coupling, and flexible and maintainable. Coming up next is the key concept. We will be looking at the core component of the observer pattern. We will have 4 concepts: subject, observer, concrete subject, and concrete observers. The subject maintains a list of observers, provides methods to attach or detach observers, and notify observers about state changes. The observers will define an interface for receiving update from the subject. The concrete subject will implement the subject. It holds important state data and notify observers when its state changes. The concrete observers, last but not least, will implement the observer's interface. They update their state to match the subject state. After that, we will be looking at the key structure of observer patterns, including the UML diagram and architecture. The figure 1, class diagram of observer design pattern. This class diagram illustrates the structure of observer design pattern, breaking it down into 4 key components. First of all is the subject interface, namely subject. It defines the contract for managing observers. It provides methods. As you can see, the 3 methods: add observers, remove, and notify observers. It only maintains a one-to-many relationship with observers' instances. The second one is the concrete subject, namely weather station. It implements the subject interface, maintains a list of observer lists, has a state variable, namely weather string, and it implements method to add, remove, and notify observers when the weather changes. Number 3 is the observer interface, namely observers. It's defined a method update weather, which will be called when the subject state changes. And last but not least is the concrete observers, namely phone display, TV displays. They implement the observer interface. They maintain a state variable, namely weather string. They implement the update weather method to receive update from weather station, and they have a display method to show the updated weather. The second figure sequence diagram of a server pattern. This sequence diagram demonstrates the interaction between objects in the observer pattern. First of all, the state changes, namely set state, is a concrete observer updates its state. Secondly, notification, namely notify. The subject notifies all register observers about the change. Thirdly, observers update, namely update. Each observer retrieves the update state using getState. Last but not least is the multiple observers. Is another observer also updates its state in a similar manner. In short, the class diagram defines the static structure of the observer pattern, while the sequence diagram demonstrates the dynamic interaction when state changes. The pattern, observer pattern, ensures that all register observers are notified whenever the subject's state changes, making it useful in real-time update scenarios like weather system, stock monitoring, and event-driven architectures. Coming up next is the implementation steps. First, we will identify the subject and observers. We will define which components produce and react to changes. Then, secondly, we create interfaces, which means define subject and observers interfaces. Thirdly, implement concrete subject, which means add methods to attach, detach, and notify observers. Next, we will implement concrete observers, which means we define the update method to handle notification. After that, we establish connections. We attach observers to the subject. Then we trigger the notification, which means change the subject state and call notify. Last but not least, we manage life cycle, which we will detach observers when they are no longer needed. What about the real-world examples? As mentioned before, we will talk about when to use observer pattern. Observer pattern is ideal for scenario where multiple object needs to update when another object changes state. Firstly, weather station application. Weather data is updated and all displays, for example, temperature display, are notified to update accordingly. Then, at the stock market, when a stock price changes, multiple applications or users subscribed to that stock are notified. We will have the event handling system examples in which the GUI frameworks like Java Swing or .NET WinForms event handler can be attached to UI element. What about benefits and drawbacks? The benefits of observer pattern including decoupling, scalability, and maintainability. Decoupling means subjects and observers are decoupled. The subject does not need to know about concrete observers. Scalability means it's easy to add new observers without modifying existing code. The maintainability means code is easier to understand and maintain it as each component has a clear responsibility. What about the drawback? The drawback of observer pattern is the performance issues and memory leaks. If there are too many observers, the notification process can become slow. And if the observers are not properly detached from the subject when no longer needed, they can cause memory leaks. We will be coming to the implementation example. Looking at our demo program, it's an example of observer patterns in a marathon race in which the observer's pattern demonstrates as the start race begins. Each observer receives the notification from subject, then all of them start the race simultaneously.
Em chào thầy. Em xin demo cái chương trình Marathon Clock của nhóm em. Dùng cái design pattern là Observer. Đầu tiên đó là em có cái subject. Thì có 3 cái phương thức là Attach, Detach và Notify. Attach là để thêm cái Observer vào danh sách. Detach là xóa Observer ra khỏi danh sách. Và Notify là báo cập nhật cho server. Thứ hai, em sẽ có một cái interface là Observer. Thì nó sẽ có update cái thời gian đã trôi qua trong cái marathon này. Tiếp theo là em sẽ có cái marathon clock, nó là một cái subject. Thì nó sẽ có cái attach là thêm vào danh sách observer của nó. Danh sách observer của nó sẽ ở đây. Và nó sẽ có cái priority là thời gian đã trôi qua, số giây đã trôi qua. Và nó cũng sẽ có một cái timer để tính thời gian. Tiếp theo là cái detach là xóa một observer khỏi danh sách của nó. Và thứ ba là notify, thì nó sẽ thông báo cho tới tất cả những cái observer của nó là yêu cầu update cái thời gian. Ngoài ra cũng còn những cái phương thức utility để hỗ trợ cho việc show thời gian ra. Tiếp theo là những cái runner. Thì runner sẽ có những cái thông tin chính như là cái tên, tốc độ của nó, và có một cái phương thức để mà update. Tại vì runner nó là một cái observer, nó sẽ update bằng cách là thứ nhất là nó sẽ cập nhật vị trí của nó, cập nhật vị trí và show ra cái thời gian và tính cái thời gian của nó. Ngoài ra thì em có implement một cái class nữa, đó là cái clock display, để hỗ trợ cho việc show thời gian ra cho người dùng xem. Em xin demo chương trình. Ở đây em đang có 5 runner, và mỗi người sẽ có một cái speed khác nhau, và thời gian chạy thì nó sẽ đồng bộ với nhau. Thời gian ở trên đây. Khi bấm start ra thì tất cả runner để bắt đầu chạy. Khi một runner chạy tới đích thì thời gian nó đi tới đích sẽ được cập nhật. Như runner 1 thì nó sẽ có thời gian bắt đầu là thời gian kết thúc là 14 giây, runner 2 là 15 giây, runner 3 là 16, runner 4 là 17, runner 5 là 19. Thì mình thấy là runner 1 là người thắng cuộc.
You can find our demo at this GitHub link. In conclusion, the observer pattern is a powerful design pattern that promotes loose coupling between objects, making it ideal for scenario where multiple components need to react to changes in a subject state. By implementing this pattern, we enhance scalability, maintainability, and flexibility in software design, especially in event-driven architectures. Thank you for your attention. If there are any questions or need for more attention, please contact us at the email above. Thank you.